Hello my students, today we are within Unit 3, Edexcel Board, October 2023. As you know, this is an alternative to practical skills or practical skills number 1. 2, they are in papers in Unit 6 or the second part of A2 Edexcel Board. You know, this paper is out of 50 marks and then it is converted to 60, and the periodic table is in the back cover of this paper. The first question is about the flame test. What he said, a student is given 3 solid compounds A, B, and C. Each solid contains 1 cation and 1 anion. 2 of the cations are known to be sodium and potassium, so he identified the 2 ions which they present in our sample. And the first part, the students carried out the flame test on the separate sample of each and separate samples of each solid to identify the cation in each. Describe the method for carrying out the flame test. He's asking you to describe, so some details are needed. First, you shall dip the nichrome wire or platinum wire, the nichrome wire or platinum wire in HCl solution. Maybe dilute or concentrated. Concentrated is better, and this is needed for cleaning. If it is repeated more than 1 time, it's better. Number 2, dip it in the solid sample of your salt, and then put the nichrome wire or platinum wire on the flame, and observe the color. Like that, you have a sample answer for the question. Now, the next question is, complete the table of the results. Here he gave you some ions and then he gave you the color of these ions. Okay. Okay, I know it's better. So this one. Now, you will find okay, 1.8 is better. Okay, the flame color for sodium ion is yellow, orange, or orange yellow. If you wrote yellow, orange, it's okay. For potassium, it is lilac. Okay. And for pale green color, it is for barium positive 2 ion, or it's a pale green color. Next one. The students prepared separate solution of A, B, and C using distilled water, and then added dilute nitric acid followed by the silver nitrate. Okay, so for silver nitrate, this is done for specific kind of anions, and each solution precipitate forms in all 3 mixtures. Identify by the name or the formula the 3 anions that could be present. Look, I will write the formula and the name, Cl negative, or what is called chloride, or Br negative, that's a bromide ion, the halide ions, or I minus iodide ion. So it is iodide. All three anions can be detected by silver nitrate test. Okay, now compounds A, B, and C each contains different anions. Describe the chemical test on a precipitate forms in B that could be used to confirm which anion was present in each compound. Give the results of each test. Now, we can arrange the tests and the result. Here we can write Cl minus, Br minus, or I minus, and this will form with part B, the AgCl silver chloride, and this will form silver bromide, and this will form silver iodide, and this is solid, this is solid, this is solid. Now, the color of each one, this one is white, PPT, and this one is creamy or cream precipitate, creamy precipitate, and this one will be yellow precipitate. That's not how to distinguish between these ions. You shall add a chemical substance. So to add a chemical substance, here you can add first dilute NH3 solution. This will be soluble. This is insoluble, and also the silver iodide is insoluble. It will not work like that. Okay, so this is yellow. Okay. Okay. So this is yellow, PPT, and this one is insoluble in dilute ammonia. Now, if you used concentrated ammonia solution, this will be, since it is soluble in dilute, it will be also soluble, and this one will be soluble, but the silver iodide is insoluble in both dilute or concentrated. Now, the next part is, or the next question, that's a plain page. Question 2. The molar volume of carbon dioxide may be determined using the reaction between calcium carbonate and ethanoic acid. The equation for this reaction is shown there. As you can see, it's an acid-base reaction, so it's very clear. That's our equation. Now, step 1, place 30 cubic centimeters of 1 mole per cubic decimeter ethanoic acid in a boiling tube. Set up the apparatus to collect the carbon dioxide produced over water in measuring cylinder. Place approximately 0.1 gram of calcium carbonate powder in clean dry weighing bottle. Weigh the weighing bottle and its contents accurately. Then remove the bung from the boiling tube and tip the calcium carbonate into the boiling tube. Quickly replace the bung in the boiling tube. Okay. When the reaction is finished, measure the volume of the gas collected in a measuring cylinder. Reweigh the weighing bottle. Repeat the experiments 5 more times, increasing the mass of calcium carbonate by about 0.05 grams each time. Do not exceed 0.4 grams of calcium carbonate. The first question is, he is asking you to draw a diagram for the apparatus that is used to carry out the reaction and collect the carbon dioxide produced over water in 100 cubic centimeter measuring cylinder. Do not show stands or clamps. Okay. Now to draw this, it's very easy. First of all, he used like boiling tube, not like this. Okay. Now we have like boiling tube and the boiling tube is connected with capillary tube that is attached with trough that is filled with water, and here we have the measuring cylinder. Okay, with okay. Now here is the measuring cylinder. Now we shall label everything, and you shall keep in your mind what we have. First, okay, wait, use this one. You see this thickness, I guess, and this one. Okay, that's the test tube, and here you shall use the plunger. Something like that. Okay, because it shall be closed. and here it's longer. This is the reaction mixture. Now what we have there is level of water. Okay. That's full, and you know it will be filled with water since the gas will replace it, and we shall label all things, like for example this is capillary tube, or what's called delivery tube. This is boiling test tube. Okay, here this is a drop, and here that's the measuring cylinder. It's very important to draw and label everything. And here what we have, this is water, so it's a measuring cylinder flipped over water, and you shall see that the level of the test tube, it will be over the water level, since the carbon dioxide comes from the delivery tube, and it will replace the water inside the measuring cylinder. Now let's go further, my students. Explain why the ethanoic acid is used and not the hydrochloric acid. Okay, when you compare the two acids, which they are ethanoic acid, as you know it is CH3, COOH, it is a weak acid, and this is hydrochloric acid, and the hydrochloric acid is HCl, and this is a strong acid, and this one is weak acid. So what does it mean that we have this difference, or this differences between the strong and weak acids? You will see that the hydrochloric acid will cause, if you return back to the procedure, let me tell you something there. For the procedure, if we return back to the procedure of the question, as you can see, place approximately 0.20 grams of calcium carbonate powder in clean dry weighing bottle. Then we remove the bung from the boiling tube and tip the calcium carbonate into the boiling tube. Quickly replace the bung in the boiling tube. So for this step, the gas, if we used HCl, the carbon dioxide produced quickly, and it will escape, or higher amount of the carbon dioxide will be escaped from the, or it is escaped from the tube before calculating its volume. So the answer for this question it will be like that. HCl, or ethanoic acid, is weak acid, while HCl is strong acid, and it will make more CO2 escape before before replacing, or let us return what's the procedure says, before the bung, okay, was returned, before the bung, return back. Okay? Now, my students, a student suggested that the mass of calcium carbonate could be measured by weighing a weighing bottle empty, and then when containing the solid, give a reason why the method described in step 4 and 7 is preferred. Okay, he weighed the weighing bottle first, and then he weighed the weighing bottle within the mass, then he weighed again the weighing bottle. So this is to describe what? He will describe the removing, or he will take in account the calcium carbonate, that was lifted where? On the weighing bottle. So he will find out, or to find out, the mass of what? Calcium carbonate was, or calcium carbonate left on the weighing bottle. Okay. Now the results of the experiments are shown. 11, 14, 20, 27, 31, 36, and 23, 29, 48, and so on. Then he asks you to draw these points. You shall draw scale, so we can draw it like that. I will take the values from the paper, and you know what's on X and what's on Y. Here, wait. So that's the table. Where is the table? Okay, first of all, we shall put here the mass. Wait. That's the mass of CO3, and here we will draw the volume of CO2, and this is in cubic centimeter. Now for the first one, we can draw it like that, 0, and here we have 0.1. 1, then 0.2, we have 0.3. Oh wait, we can select better scale like that. For example, here this is 0.1. Okay, then 0.2, 0.3, and this 1.4. That's the mass of CaCO3. And the volume scale, it will be 10, then 20, 30, 40, 50, 60, 70, 80. Okay. Now, to draw the points, the first one is 0.11 with that. So you can draw it, and you will see that you have a linear relationship. You shall draw the points and find the linear. Everybody can have this scale, and you will find that this is the shape of the curve. If you draw it, you will find it is a linear shape. And after that, we can go further within the question. Use the graph to determine the volume of the carbon dioxide formed with 0.25 grams of calcium carbonate is used. Okay, you can return back and you will see from this point where is the calcium carbonate when this 0.25 grams. This will give you this answer. Okay. This will give us this answer. It's around 52.5 cubic centimeter. Keep in your mind this volume, which is needed to react with 0.25 grams. Okay? Now, what is left? Calculate the value for the molar volume of carbon dioxide using your volume from DII and the equation for the reaction. Now, what we have the 0.25 of the mass of calcium carbonate, and we found the volume which is used for this number of moles or this mass. So first of all, you can find the number of moles by dividing what? By dividing the mass which is used over the molar mass. So the molar mass, okay, it is for calcium carbonate, the molar mass of calcium carbonate is 40.1 plus 12 plus 16 times 3. So this will equals 100.1 grams per mole. And then you will find the moles of CaCO3. That's 0.25 grams over 100.1. This equals 2.4975 times 10 to the power negative 3 moles. And then you can find this number of moles equals the moles of CO2, which is 2.4975 times 10 to the power negative 3. This, the volume is, you will know that number of moles equals volume over molar volume. So he is asking you to find the molar volume. Again, you will find the molar mass of calcium carbonate, which is 100.1 grams. That's the molar mass. Then you will find the moles, which is the mass over the molar mass, and that's the number of moles of calcium carbonate. And then the number of moles of carbon dioxide is the same, 2.4975 times 10 to the power negative 3. Now you know that the number of moles equals the volume over the molar volume. So the molar volume is the volume over the number of moles. This is in a cubic centimeter. It is converted to cubic decimeter. That's the final answer. Okay. Now, he's asking you to give 2 reasons why the molar volume obtained by this method is lower than the data booklet. Assume that the experiment is carried out correctly and the gas volume was measured at room temperature and pressure. So this is because of the 2 reasons there. Some of, you will see, some of CO2 gas was escaped when the plunger was removed, escaped, and some of CO2 was dissolved in water. Now this is what we have in question 2. I will continue the paper within the coming